All right, welcome to Chapter 6, Section 3, Elimination using addition and subtraction. We're still talking about systems of equations for this one because we're still, Chapter 6, we started with systems of equations. So this is for IM1 or Integrated Math 1. Just go over a few of the screen features here. You should see a due date right here in front of attempts. I don't see it on the teacher preview, but it'll definitely be on your screen as a student. Attempts is the next piece here. You always have unlimited attempts, so you can come in and try this assignment as many times as you would like. This tells you how many questions there are on this particular assignment for this section. Grading policy is best score, so whichever attempt is the best one is one you get to keep. Partial credit is enabled, meaning, if you answer 1 of 3 questions, that you get credit for the 1 question. And please remember, once you start the homework, you must finish it before you can work on anything else. What that means is when I click Start down here, in the bottom right-hand corner on your student screen, you will see a Submit Assignment button. So no matter what, at this point, if you want to leave this screen, whether or not you haven't started anything or if you've only done a couple of the questions, you click Submit Assignment button. It does 2 things. It stops the system from locking you out of all the other assignments, like it said on that previous screen, and it puts it in the grade book, so it actually makes a difference in your grade. We get to see what you're working on as a teacher. It'll save your place, so it's not going to reset any questions. As long as you click the check button and gotten the little green check up here, you will keep that when you come back in on your next attempt. All right, you also will see 3 buttons on the side here. We have explanation, which tells you you're going to lose your current question attempt because it's going to give you a solution to this question. So it's not going to give you the answer and then let you come type it in. Sorry, that's not how this works. It'll X off the question. You'll have to come in on another attempt to actually get points for it. Example gives you just a general example for this problem type. So it's not super general, but it lets you see. So like this one, I kind of like the color coding they have here. We have 2 equations, and we can see red is for the x variable and coefficient. Sorry, I lost my train of thought there. And then blue is for the y and the y coefficient, and then this kind of brown color is for just the constants, the numbers. So they have it matched up so that we can actually see when we're talking about elimination, what we want is something to go away. That's what eliminate means. It's canceling out. So if I subtract straight down for these 2, 6 minus 6 is 0. That canceled itself out. 7 minus negative 9, and we want to be careful with this one because actually what they did was they applied the negative already. So we have 9, or negative, negative, negative. They were positive, positive, positive. So it's not minus negative. Sorry, I was saying that funny. I was thinking this was the minus out in front, but they applied the negative. So it's just 7 minus 9, so negative 2. 4 minus 12 is negative 8. And now I can solve for this because I have 1 variable left. So this is just another way to solve systems of equations is all this is. So this is the 3rd method we've learned so far. There's graphing, there's substitution, and then there's elimination. So we have, all right, so if we're looking at these, we also have message center in here too, so you can message your teacher directly. All right, so I'm going to write these ones out, and I think I'm going to do something very similar to what they did there. So I don't have brown chosen, but that's okay. So I'll go 7x and 4x plus, you know what, I'm going to go ahead and do the pluses in red because technically the pluses belong to these 6 y's, like this. And then equals, instead of brown, I'll use pink because I just don't have a brown one pre-selected there on my little color wheel. All right, so now I have my color coding here. So they're not going to color code it for you on Alex on this screen, but you can do that on your own. You don't have to color code it. It's just a way so we can identify things very quickly. So the x coefficients do not match. If I subtracted these, I would not get 0. But 6 minus 6 would get me 0. So what I want to do is I want to subtract this whole bottom. And when I subtract the whole bottom like this, I have to make sure that I apply this negative. So when I apply the negative, what it means is everything is going to flip. So instead of positive 4, it's going to be negative 4. Instead of positive 6, it's going to be negative 6. Instead of positive 8, it's going to be negative 8. So everything flips over. If something was negative, it would have flipped to positive. So you apply that same rule because we're going to subtract everything on the bottom from the top. So now I have 7 minus 4, I get 3x. 6 minus 6 becomes 0. It cancels out. And I don't have to put plus 0y like it was showing on the example screen. You can if you want to, but 0 plus 0 doesn't change anything. So it just kind of cancels out and goes away. -4 minus 8, they're both negative. I have -4, I'm going 8 more negative, so it's -12. I just add them together and keep the negative sign. So to solve for x, my only step here is I'm multiplying by 3, so I'm going to divide by 3. That's my opposite operation here. 3 divided by 3 is 1, or just 1x. -12 divided by 3 is -4. So now I know what my x is. I'm not done yet. Now I need to go back and plug it in here to either one. It doesn't matter which equation I plug it into. It truly doesn't matter which one. I'm just going to choose one of the two equations, and you can actually do it to both to see if you don't get the same answer for y, something went wrong when you were doing this step. So we should get the exact same answer for both. So I'm just going to go ahead and choose the top one here. So I have 7 times -4, that's x. I'm just plugging it in here. Plus 6y equals -4. So we're plugging this back in because I need to know, what does y equal? I don't know what that is. That's what I want to go through and plug this in for. So I get -28. 7 times -4 is -28. Plus 6y equals -4. I'm going to add 28 to both sides because now I'm trying to get y all by itself. So I want to look at what's being done to y. It's being multiplied by 6, and it's being subtracted by 28. Okay, this plus belongs to the 6, not the 28. So this is subtraction here, but we say -28 or -28 plus 6y. It depends on how we're reading it. But negative and minus mean the same thing. If I have a minus 6y like I did up here, that actually means it's -6y. But in the sentence we read it as minus. So it's just changing the words to match the sentence. That's all it is. So I'm going to add 28 to both sides. -28 plus 28 cancel out. I have 6y equals -4 plus 28. They're opposites. So I'm going to subtract. And I have more positive than negative. So it's going to be a positive 24. And then just like I did with the 3 here, it's being multiplied by 6. I'm going to divide by 6. 6 divided by 6 cancels. Any number divided by itself becomes 1. So y equals 24 divided by 6 is 4. So we have 4. All right. So remember, you want both of these because this is a system of equations. So this says that these two lines will cross at this point here. And I know we've played with Desmos a few times. So this is a graphing calculator, desmos.com/calculator. It's a very cool tool. So you can actually use this to visually see what this means. So I have this line. So I have this line here. That's my first one. And then I can click on this second piece here and go 4x plus 6y equals 8. And then I have a second line. And I can see here is my solution, just like we found with using the elimination method there. So either way, I can solve this by graphing because it's integers. So this wouldn't hurt. I could definitely solve this very easily by graphing it. I could solve this using elimination because it's already set up for that. You could also use substitution for this one if you wanted to set it up that way. But that one would take a little bit more doing because it's not ready for it. It's ready for either graphing or elimination. And because they're in standard form where x and y are both on the same side, it's kind of more set up for elimination. It's already set up. Oops. Didn't want to close that. It's already set up to do this subtract straight down idea. So you just want to choose of the 3 methods, which one is the easiest? Which one is it already set up for? And because we're in the elimination stage here, or the section, most likely it's set up for elimination. Kind of, just thinking that piece through. So I'm going to go blue. We have 5x and 5x. So I can already see those guys match. Plus 6y plus 3y equals -10 and 20. All right. So now I want to go through and I want to subtract because some things should eliminate. Now, in this section, I believe because we're only using addition subtraction, it's not in the next section, we're going to learn about having to multiply a little bit to tweak this to get it where we want it. Something in this section, though, when we're doing this, something should already match. So the x's already match. Their coefficients are both 5. So when I subtract the whole piece here, remember, I need to apply this negative to everything. So it's going to be -5, not +30, -30, not +20, -20. So just make sure you're applying that to everything. You're kind of giving everything a negative sign. So if it already had one, remember, if it was already a negative number, then it would be a positive number. So like if we had done this to the top, this would have switched to a +10. But we did it at the bottom where everything was positive, so kind of made it easy there. So 5x minus 5x cancels out, right? Becomes 0. 6y minus 3y becomes 3y, because 6 minus 3 is 3, equals -10 minus 20. I have -10. I'm going 20 more negative, so I'm going to add and keep the negative sign. So now, just like we did on the previous one, it's multiplied by 3 here, so I'm going to divide by 3, and y equals -30 divided by 3 is -10. So now I need to take either one of these equations, or both, and plug this in. So I have 5x plus 6y, and y we just found is -10. I'm substituting. So we learned substitution on section 2. If I know y is equal to -10, I can substitute it. Instead of writing y, I can write -10. So, and I did that on the last one without really reviewing or explaining, but that's the idea there. It's a substitution. So now I have 5x, 6 times -10 is -60. It's -10. So now I'm going to solve for x. I want to get it all by itself. So x is being multiplied by 5, and it has -60, or subtract it by 60. So I want to do subtraction, addition or subtraction first. So the opposite of subtraction is addition. So I'm going to add 60 to both sides. And again, this is kind of another idea of elimination. It's -60 plus 60, they cancel out. They eliminate. They go down to 0. -10 plus 60, they're opposites, so I'm going to subtract. I have more positive than negative, so it's going to be +50. And my last step here is to do my division, because I want to cancel out the 5s. 5 divided by 5 becomes 1. 50 divided by 5 becomes 10. So this would be another coordinate. I'd have 10, -10. 10, -10. And again, if I go over here to this guy, I can even test this out and say it's 5 and 6, and this is 10. So it moved that line a little bit. And then this is 5 and 3 and -20. So I can see this point. Uh-oh, what happened? Oh, not -20. That's why. There we go. So now I can see that point is correct over there, 10 and -10. So make sure you're paying attention when you type them into the graphing program so that you can kind of see it a little better there. The only problem with this one is don't become super dependent on Desmos, because when you're doing certain tests and like the state testing and things like that, you're not going to be able to pull this graphing calculator up and use it this way. So this is a really cool way to check your answers, or to visually kind of see what your answers look like, but don't get dependent on this to get your answers from. You want to know how to do the algebraic method with this so that you understand how to do it without the graphing calculator. Because although they are wonderful, they're not always available to us. It's definitely a very cool way to be able to see your solution, though, so you can see where those two lines cross. Okay, let's do one more of these guys. Okay, so now we have the sum of two numbers is 56, and the difference is 2. What are the numbers? So when we're writing systems of equations, when they have a word problem, they're writing it, we're going to have two different things that we're comparing. So two different quantities. Sometimes it's, you know, an actual quantity and like an amount you're buying versus the cost, or I think we've done number of minutes versus the cost, renting a car, cost and miles driven, you know, things like that. Like there's two quantities. In this case, the two quantities are simply the sum and the difference. So the sum means, addition. The difference, sorry, that's supposed to be a C, means subtraction. like that. Sorry, I had an arrow and then not an arrow for the second one. So we need to know those words. If we don't know those words, that's definitely something we want to practice so we can identify those words very easily. And we've done that a few different times throughout the semester, just taking a look at what do these words mean. So if you hear the sum, that means we're adding. If we hear the difference, that means we're subtracting. So I have two numbers. It's larger number and smaller number. So I can use L for larger and S for the smaller. You can use any variables you would like. Really doesn't matter which one. And in fact, instead of S, I might even use N because my S's look just like 5s. So that's why I tend to write it like that with that weird little thing. And then students ask me why I'm using the dollar sign. So if I add them together, the sum of the two numbers is 56. There's my first piece. There's my first equation. My second equation, it says the difference is 2. So if I subtract them, their difference is 2. So if I add them together, they're 56. If I subtract them, they're 2. Now we could probably go through and try to figure out numbers. They're obviously going to be lower than 56 if they add up to 56. And we could go through and kind of try to figure that out. They're also going to be pretty close to each other because there's only a difference of 2. So it's going to be somewhere around the halfway mark. So we might be able to kind of finagle this one and figure it out by trial and error. But we can also use this elimination method. So I have L and L. Those both match. N and negative N. Ooh, when we have one positive and one negative, instead of subtracting from top to bottom, I can just add them. I don't have to apply a negative sign here, which is nice. So I have L plus L is 2L. N minus N cancels out. Anything minus itself, just because it's a variable, doesn't change those rules. So now I have equals 56 plus 2 is 58. So now I have times 2, and I can divide by 2 on both sides. 2 divided by 2 is L. 58 divided by 2, let's see, what does that give me? 29, I believe. Yes, 29. Because 9 times 2 is 18, and 20 times 20 is 40. So 40 plus 18 would give me 58. So the larger number is 29. Now, to get the smaller number, I can go back to either one of these equations. But this one's definitely pretty easy. If I say 29 minus the smaller number gives me 2, then I can just simply kind of figure this out and go, okay, well, I'm going to solve by moving this over to the other side. It was positive 29, so I'm going to subtract it. 29 minus 29 cancels. I have negative N equals 2 minus 29 is 27. I have more negative than positive, so it's negative 27. But I also have a negative here, so I'm going to move it to the other side, and 27. You might not have needed to solve that necessarily if you said, well, if I subtract the smaller number from 29, I'm left with 2, which means that it's 2 smaller than 29, so that's 27. So once we get that first one, sometimes the second one's a little easier to just kind of conceptually think about, where does it need to be in order to get the correct answer. Or you could have even done this one and said 29 plus N equals 56. If I subtract 29 from 56, I'll be left with 27. So just another way, another system of equations there. It's just kind of it's a very simple statement, but you end up with 2 equations from it because there's 2 different types of information or 2 different quantities, a sum and a difference. All right, that was section 3. I will see you in section 4.